Today we are going to study about fronts and their types. To start with, we need to understand what are fronts and how are they formed. You must have come across the term air masses in some of our previous lectures. An air mass is nothing but a body of air that is found either over land or sea or combinedly, which can be recognized through its uniformity in features like temperature or humidity, etc. These air masses are found throughout the world. We can differentiate them on the basis of their location. Like, for example, we have the continental air masses or the polar air masses, the tropical air masses, and so on. These air masses, because they differ in temperature and humidity content, plus density and the atmospheric pressure that they carry, it happens that when two different air masses with a contrast in their physical characteristics like temperature, humidity, density, air pressure, etc., are converged together, they don't get mixed up in an easy manner, resulting they form sloping boundaries. These sloping boundaries are the transition zone through which we see that there is a change in weather elements in the particular area. This the line of discontinuity, where the two different type of air masses are merging up, is known as front in geography. These front usually act as the areas where we find different types of weather conditions. Majorly, the weather fronts are divided into four types: the cold front, the warm front, the occluded front, and stationary front. Let us start with the first, the cold front. A cold front is usually defined as the front along which the cold air mass is invading in the warm air zone. We can explain this easily with the help of a diagram. If we have a warm air mass and the cold air is pushing towards the warm air mass, what usually happens is cold air being dense and heavier, it pushes the warm air upward in a slant, in a slope, and forces the warmer and lighter air mass to move to a altitude. As the warm air is pushed upward, it when it reaches an altitude, it starts condensing and thus results into heavy showers or rainfall at the zones of the front. The second type is a warm front. Under this warm front, the warm air is proceeding towards the cold air mass. Warm air being lighter could not push the cold air. As a result, it itself climbs over the cold air mass and is slanted upward, is forced to move to push itself upwards the cold air mass. Thus, again, leading to the process of condensation as it has reached a height which results into heavy showers, heavy precipitation at the frontal zone. One point to notice here between the cold and the warm front here is that during the phase of cold front, the warm air is pushed at a high altitude in comparison to the warm air front, because here the force is done or created by the warm air, so it does not because it is light, so it does not has that much of a force that it can climb at a high altitude. So in a comparative study, we'll say that under the cold front condition, the warm air is pushed at a higher altitude in comparison to the warm front. The third is an occluded front. This is the situation where a cold front overtakes a warm front. This is the situation of the cold front. This is the situation of a warm front. Here, the cold front is taken over by the cold front takes over the warm front. So the situation becomes like this. Because the cold front is denser, it tends to move in a rapid manner in comparison to the warm front. As a result, the warm sector is progressively reduced in size, and ultimately the cold front overtakes the warm front and displaces the warm air at the ground. As the warm air is pushed upward, here again the same condition occurs. It condenses, forms clouds, and heavy precipitation can be seen in this zones. Now, one thing to note here again will be that precipitation need not essentially be in the form of rainfall only. It depends on the temperature of the cold air mass. It sometimes also turns into snow in these particular areas. So, any form of precipitation can be witnessed in these areas. The last one is a stationary front. It is like the term itself says, a stationary position. Here, both the cold and the warm front are stable and are not moving. This creates the wind motion on either side of such a boundary, and it is nearly parallel to the position of the front. And whenever some warm air is overrunning these stationary fronts, it leads to precipitation in these areas. So these were the fronts and its different classifications. Thank you so much.